Very high frequency omnidirectional range, or VORs. These are aligned with magnetic north at the station. They are free from static interference. They can be used during the day or night. The frequency range is 108 to 117.975 MHz. They have an accuracy of plus or minus 5 degrees by day or night. The principle of VOR is bearing by phase measurement, resulting in a Limassol polar diagram. NDB bearings are transmitted omnidirectionally and are measured at the loop aerial on the aircraft. For VORs, the bearing is established at the transmitter, and depending on where the aircraft is in relation to the VOR station, it will receive signals that define the bearing of the aircraft from the VOR. Transmission details. There are 40 channels in the allocated VOR frequency band according to ICAO Annex 10 from 108 to 112 MHz, mainly allocated to ILS localizers and terminal VORs. There are also 120 channels allocated between 112 and 117.975 MHz, mainly for VORs. Note, all VOR frequencies are allocated with the even decimal digits, for example 108.05 or 108.45. All ILS frequencies are odd decimals, for example 108.1 or 108.35. Identification. All UK VORs use 3-letter Morse code idents every 10 seconds. However, the ident can be in a voice form, but always has the Morse code ident after it. A continuous tone or a series of dots indicate that the VOR is in test mode and should not be used. If you hear nothing, then do not try to use the facility. Monitoring. All UK VORs have an emission code of A9W. A means amplitude modulated, double sideband, 9 is a composite system, and W means a combination of telephony and telegraphy. All VOR beacons are monitored by a facility known as an automatic site monitor. It will remove the use of the facility if there is a bearing inaccuracy of more than 1 degree or a reduction of greater than 15% signal strength. VOR operation. When due east, magnetic of a VOR, the AM and FM frequencies are 90 degrees out of phase. When due south, they are 180 degrees out of phase. When due west, 270 degrees out of phase. And when due north, the AM and FM frequencies are in phase. Always apply variation at the VOR when using the facility. Types of VOR. CVOR means conventional VOR, a first-generation VOR station emitting signals by means of a rotating antenna. BVOR is a broadcast VOR, providing weather and airfield information between idents. DVOR is the second-generation VOR station emitting signals by means of a combination of fixed antennas utilizing the Doppler principle used to overcome site errors. The en route VOR is for use by IFR traffic. A TVOR, a terminal VOR, is a low power, shorter range and used as part of the approach and departure structure at major airports. A VOT is a test VOR found on major airfields broadcasting an omnidirectional signal but reading 000 as the radial. It is not used for navigation but used to test VOR indicators in an aircraft. If you have an error of plus or minus 4 degrees, the equipment should not be used. A VORTAC is a co-located VOR and a TACAN, a military aid, DME beacon. AFIS and ATIS are Aerodrome Flight and Terminal Information Service broadcasts. Operational range. The higher the transmitter power, the greater the range. The en route VOR is 200 watts and a terminal VOR is 50 watts. Maximum theoretical range is equal to 1.23 multiplied by the square root of the aircraft height plus the square root of the transmitter height. VOR errors are sight error, caused by uneven terrain such as hills, mountains and buildings, and is known as scalloping. Propagation error. With increased range from a VOR, the accuracy decreases. Equipment error, caused by other electrical items in the aircraft interfering with the VOR signal. The cone of confusion. Directly above a VOR is a cone of confusion of size 100 degrees. This is an area where the signal cannot be received due to the horizontal polarity of the aerial. Therefore, the instrument flutters about and in some cases shows a failure flag. VOR ILS deviation indicator. The display shows that the pilot has selected a radial of 0802 and that the aircraft is slightly right of the selected radial. A rule to remember is that a full-scale deflection is always 10 degrees. Therefore, if the dial has 5 dots, then 1 dot equates to 2 degrees. By looking at the above dial, the aircraft is 4 degrees right of the selected track. Note, the co-located VOR DME means that it's 2,000 feet within an airway and within 1,000 feet on an airfield. Doppler VOR. These are second-generation VORs, but utilise the same transmission frequencies emitted by a combination of fixed antennas using the Doppler principle. The advantages are that they suffer from fewer errors and have an improved accuracy. They differ from conventional VORs by having a reference signal of amplitude modulation and not frequency modulation, as well as having variable FM signals. Most of the time, you would not realise you are using a Doppler VOR, as it allows you to use the same instrumentation on board the aircraft, but with improved accuracy.